Welcome to Module 5, Lesson 8. Today in class we did some 3D sculptures with rectangular prisms. Lots of fun. Our homework is related to that. And the big question is, what happens to volume as I change my dimensions? So, if I start out with a basic box here, and it has a certain volume, whatever that volume is, 1, 5, 10, if I want to double its volume, I need two of those. And if I do that, I get something like over here. Notice the height remained the same, the depth remained the same, only this length doubled. So when I double one dimension, then my volume doubles. Reverse is true. If I cut one dimension in half, my volume gets cut in half. If instead I were to double two dimensions, this dimension and this dimension, notice my volume is quadrupled. It's times 4. And if I had actually done that in the vertical direction as well, my volume actually is times 8. I have 1, 2, 3, 4, and then 4 on the bottom, 8 the original volume. So that's important to realize the effect of doing more than one dimension at a time. For these problems, we're only going to be messing with one dimension. In this problem, I have an original rectangular prism that is 16 meters by 8 meters by 24 meters. That's going to give me a volume, 3,072 cubic meters. Now it says here I want to get 3 new prisms, and each of them needs to have a volume that's 1/4 of the original volume from the original prism. So like I said, I can get something that's 1/4 of it if I only mess with one dimension. Luckily, all our dimensions are nice multiples of 4, so I can cut the original length into 1/4, and I get 4 meters, and I leave the other two alone. They stay the same. And that'll give me a volume of 768 cubic meters. I get that number whether I divide the original volume by 4, take 1/4 of it, or if I just multiply my 3 new dimensions. Now for another prism, I could leave the first dimension alone, and I could cut the second one by 4, leave the third one alone. Or I could leave the first one alone, the second one alone, and cut the last one by 4, take 1/4 of it. Either way, I'm going to keep getting 768 meters cubed. Now, if I had messed with more than one dimension at a time, I would have had a problem. The other problems on this problem set are, or the homework, are variations on this concept. Just make sure that you're only messing with one dimension at a time and you'll be fine. That's the end of the lesson.